kinds of transformations we worked with. What were they called and what did they do? What were they called? What's their official name and what did they do? What motion did they do? Someone give me one of them. Starts with a T. Okay, so the three types are translation, rotation, reflection. Yes, but we need to know what it's called and what it does. So translation, yes, Moses, what does it do? What does translation do? Slide. Thank you. Somebody else. We know one is called rotation. So what is rotation? What does it do? Someone else but Moses, he just did one. So Lex, reflection is one of them. What does it do? Like a mirror. So what do we say? What's the easy word that starts with an F? Flip. Yes. Okay, so we have translation, slide. We have reflection, like a mirror, it flips. And then what's our third one again? And what does it do? Okay. So we said translation slides, reflection, like a mirror, it flips. What's our third type and what does it do? What is our third type and what does it do? Rotation, and it spins or turns. Okay, so we did those last week. Now, when we did those, did it change the size of the shape? Did it change the size of the shape? No. That's why those were called rigid transformations, because all they did was move it around. It just moved it around. One did a left and right move, up and down move, sliding. One of them did a spinning move, and one of them did a flipping move. But it didn't change the shape. The shape stayed exactly the same. It just turned its orientation, flipped its orientation, or slid to another piece of the graph, right? We all okay with that? That the shape didn't change anything at all last week. Okay, so this week we're going to introduce a fourth kind of transformation, but it is going to change things. Okay, it is going to change things. So be prepared that we know it's going to change things. When all the x and y coordinates of each vertex of a shape are changed by adding or subtracting the same number, the shape translates to a new position. You learned that in 6.1.3. That when one of the coordinates of the vertices, either x or y, is multiplied by -1, the shape is reflected. If the x is multiplied by the -1, it's flipped over the y-axis because it's going over that. Remember, with our reflections, it's where we fold the paper. The other one is the one that changes. So if we're folding the y-axis, the x is the one that's changing positions, -1. When we fold it top to bottom, the x-axis is where it's folded, so the y is the one that's changing. So whatever one is folded, the other one is the one that's changing. So we learned about the sliding, we learned about the reflecting. How do you think the shape is going to change when both the x and y are multiplied by some number? So we're going to use these directions to graph and change things, okay, so we could see a new type of transformation. Okay, step one, we got to graph our original points. So let me get this where I can do it. Okay, so what color do we use and which tool? if we're making our points on the graph? What color and which tool? Yes, it's either blue or red. Which one of our tools do we use to make the drawing tool? And we make sure we set it to a 4, right? So I have to pick red or blue. I'll pick red. Oops, I forgot to do something. What did I forget to do? What did we forget? What did I forget to do on this worksheet? Forgot to say who I was. Kind of important. Now I know we're virtual and I know it's in your book, but in your Google Classroom, and I know it's yours. But remember, we're trying to keep those, practicing those skills that when we go back in the fall, we know and we don't have forgotten. Okay, so this is Mrs. C, period 2. Okay, thank you. Okay, so now I got to get the graph up here a little bit because we have to graph these points. Got to graph the points. I'm going back to my drawing tool. And I want it on 4, so the dots show up. Because if you leave it on 1, the dots are too small, you can't see them. And if it's too big, then it takes up too much space. So I do want to zoom in a little bit though, because it's easier to see my corners and my lines. So I'm gonna be ready. So first one is 2, 1. Center is always 0. First number is always left and right. If it's 2, that means positive 2. Is that going to be left or is that going to be right? Because some of you are still having problems with your graphing. We're practicing that right now. So if I say positive 2, it's going right 2. So 1, 2, and I hover, I don't make the dot yet. And then it says positive 1. So which way am I going to go? One up, and then we put the dot. Okay, and as much as possible, I know it's kind of tricky, you need it to land exactly where all 4 boxes meet, okay? All right, next one, 3, 3, 1. That means it's over 3 up 1, right? How about 5, 5? Where's that going? What's 5, 5 going to do? If I say 5, 5, what's it going to do from the center? Right 5, up 5. Got it. Thank you. And then we have a 2, 5. So what are we going to do? Two, 5. What's that going to do? Okay, right 2, up 5. 1, 2, 3, 4, 5. Okay, now we have a shape and we are going to go get our shape and get our line and pick the same color as the dots you used. So if you use blue, pick blue. If you use red, pick red. And we're connecting dots. There's one. Quit that. There's one. So it's still 4 sides because there's 4 dots to connect. Anyone know the fancy name for this shape that has one set of parallel lines? Give you a hint, it starts with the letter T. Give you a hint, it starts with the letter T. Anybody remember what it is? That's only got one pair of parallel lines and the other ones are not parallel. Starts with the letter T. Not a triangle, because triangles only have 3 sides. Great, you got it, Brian. Trapezoid. That's one of those really weird words. Okay, so we got our trapezoid, so we can be more specific than just say quadrilateral. We know he's got a name. Now, the only time we stick with the name quadrilateral for the whole time, quadrilateral, is when all 4 sides are kind of wonky, but there's 4 sides. But this guy has a name. His name's a trapezoid. So now let's look at B. B says, without graphing, predict what you think the figure would change, how the figure would change, how the figure would change if the x coordinates and the y coordinates were multiplied by 2. So we're going to do it without graphing. They said without graphing. So what do we think is going to happen if our x number and our y number for each of those 4 spots is multiplied by 2? What do we think is going to happen? What do we think is going to happen if we multiply the x for each of them and the y for each of them by 2? What do we think is going to do to the figure, the original shape that's on the graph? Is it going to stay the same? If I multiply the x and I multiply the y, will it stay the same? I'll wait on you. We don't think it'll stay the same. How do we think it's going to change? The shape will, how do we think it's going to change? If I get larger, okay. I got to do this in a second. I got to tell it's really me. Yes, it's really me. They did some updates this weekend and they're like yelling at me. Okay. The shape will get larger. Okay. So now let's go do the math to prove that it's getting larger. So I'm going to take my equation, am I blue or red? Doesn't matter. And I'm going to take each of my points that I have that they gave me, okay? And I'm going to do what they told me to do, multiply the x by 2 and the y by 2, and then graph those. So my first one was 2, 1. It is changing by doing 2, and then we go over here to the symbol, times 2, 1 times 2. And we're making a new coordinate of what? What would the new number be? What would the new coordinate be? Do the math. 4, 2. Okay, so I'm going to repeat that for all of my other 3 coordinates. So I'm going to work smart, not hard, and I'm going to copy and paste this and then just change it up for each of the coordinates. So I need 1, 2, 3 more. I'm going to move it in a second. 3 more. Once I get stuff written, I usually shift it around to make space. It's easier. And I'm going to change up the numbers to be what they are from part A. And we're going to do the math and find out where it's going to land. So my second one in part A was a 3, 1. So that means 2 times 3 times 2 and 1 times 2. So what's that one going to be? 6 times 2. My next one was 5, 5. So I'm going to put a 5, 5, 5 times 2 and 5 times 1. No, 5 times 2 and 5 times 2. Is what? Ten. So all I'm doing is taking the coordinates from A and doing what they told me to do, which is multiplying the X and the Y by 2. And the last one was a 2, 5. So 2 times 2 and 5 times 2. What's that going to be? 4, what? 4, 10. Okay, so these are my new coordinates that I need to graph. So I'm going to use a different color. So if you started with red, then switch to blue. If you started with blue, then switch to red. So we're back to our drawing tool. I want a different shade of blue though. I want a darker shade of blue. Where are my blues? There you are. Okay. So I'm switching over to blue for these. Okay, because I want to be able to see the difference. All right. So the first one changed to 4, 2, right? So 1, 2, 3, 4, 1, 2. What did the second one change to again? 6, 2. Okay. So that was 4, 5, 6, 2. Okay. What's our third one now? Okay, so 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the other one was, what's our last one? 4, 10. Okay, so 1, 2, 3, 4. And I know it's going to be the same height as this one. And then I got to connect those. And we're going to put on all of these their coordinates so that we can tell them apart. Oops, no. JK. Line feature. Change to blue. Remember, if you were red, switch to blue. If you were blue, switch to red. So that you could tell the original apart from the new one. Okay, so we need to put on the corners of these their coordinates, and we have them all. We already have them. They're right here in this math work. My original red ones were the first coordinate of each one of these, right? So I'm going to go put those next to their dots. And I am going to change how big they put in there because we don't need them gigantic. And like I said, I recommend you do the fill of white so that they stand out a little bit. Okay, let me go get my next one. Put it next to my next dot. So we're repeating this for all 8 dots that we have. Okay. Now remember, the red one was the first coordinates and the blue one is the last coordinates. So we already have them. We just have to copy and paste them onto the graph, which makes it kind of nice, right? Easier to deal with. Okay, there's my first ones. Now I got to go put my other ones. And I am changing over my color to blue at this point so that I can differentiate. Anybody confused about this part? The labeling part? where we're getting the labels from or anything like that. Now notice this 4-2, I have to slide it over a little bit so it doesn't use up part of my red line, which means I'm going to put the second one next to it. It doesn't matter that it's perfectly next to, it's just got to be close so the person can say, oh, that one must be, right? So working smart, not hard. We use pieces we've already done instead of having to redo it, recount it, re-any it. Don't want to retype it either. I can do it. Okay, so we got all our coordinates on. Everybody agree? Okay, now it says test your prediction of doubling coordinates from part A and plotting them on the graph. Okay, so we tested it. We plotted it on the graph. We saw it got bigger, but what we didn't see was how did they get bigger? How much bigger did it get? How much bigger did it get? We multiplied the x by 2 and the y by 2. How much bigger is our shape than our original? Is it the same size? Is it 2 times as big, 3 times as big, 4 times as big? We sure it's 2 times as big? Because we've got to think about it. When we talk about the size of our shape, right? The easiest way to compare is by area. So we're going to figure out the area of shape 1, which was the red one. And we're going to figure out the area of shape 2, which is the blue one. And we're going to see how much bigger it really is. Okay. So we're using our equation. Trapezoid area. 1/2 times the quantity of base. And what we need to do is go subscript. So let's see how we get there. Let me see if you're in here. Because we need to say base 1, base 2. Okay, we'll just do it as a base 1, base 2 instead of a sub. Normally in math, you're supposed to put the little 1 and 2 down below, right? It's supposed to be not even with the letter, but I don't see how to do that in here. So base 1 plus base 2, oops, times our height. That's our area formula. So let's go label and count. All right, we are counting the red shape. How far is it? How long is the top line? What's that size of the top line for the red one? How long is that red line at the top? That's base 1. So count how many squares it is from right to left, left to right for that top red line. How big is that red line? Somebody count it. Top red line, how many? Three. Okay, thank you. Okay, so we're going to put a 3 there. Count the top red line, top blue line. Top blue line. So this one was 3. Top blue line is 6. Okay. And that makes sense because we did, you know, each X and each Y by 2. So if the first one is 3, then the second one makes sense to be 6, right? Okay, so now we got to go do the up and down line that's on the left side for each one. How many? We're just counting the sides right now. 4. Okay. How about for the blue one? 8, which makes sense because we times by 2. Now, this one that's straight up and down, this is our height. So that's our H for our formula. So I'm going to put that in there so we know that's our H. Now, height is always straight up and down. Okay, height is always straight up and down. This top is base 1 for both of them. So what do we think the bottom is going to be? If the top is base 1, oops, no, I don't want to do that. If the top is base 1, what do we think the bottom is going to be called as a name? I'm going to fix this in a second. Base 2. I need to move this H out of the way so I have space. Okay, so we need to count base 2. We do not care about the slanted line because there's not a space in the formula for it. There's a space for base 1, there's a space for base 2, and there's a space for height. And height is always straight up and down. So that's always the one we worry about for trapezoids. So we need base 2. So we got to count the very bottom of the red one and the very bottom of the blue one. Well, what's the very bottom of the red one going to be? How many squares is it taking up? 1. Okay, and the very bottom of the blue one, how many squares is it taking up? So I'm just copying and pasting. 2, yeah. Okay, so let me fill this so it doesn't have that line through it. That should be filled white, yes. So this base 2 is 2. So we have all the numbers, base 1, base 2, and height, right? So we are going to take this formula, base 1, base 2, and height, and we are going to go ahead and work it out for both the red one and the blue one. We're going to put our numbers in, okay? First time we put it in, we're going to do the red ones. So I'm changing it to be a red. I am replacing the base 1 with the red base 1, which was what number? What did we say the red base 1 was? How much did we say base 1 was for red? Look where you said B1 for red, and how much is it? 3, okay. And then how much did we say is base 2 for the red? 1. And how high did we say the red was? 4. Okay. Now we're going to repeat this process for the blue one. So I'm going to copy what we just did, change the color, and we're going to stick the blue numbers in. Okay. Base 1 for the blue. How big? We're not calculating yet of the red, just base 1. We're just going to stick the numbers in for the second equation. Base 1 for the blue, how much? Base 1 for the blue was how much? 6, okay. Base 2 for the blue was how much? 2. Height for the blue one was what? 8. Okay, so all I did was stick the numbers and I haven't done any math yet. We're going to go do the math now. So whenever I see this fraction on the outside in a parentheses, because all of these things are multiplying, half times base 1 plus base 2 times 4, I can rearrange how I do them. Because multiplication, you're allowed to swap them around, because 2 times 3 is the same as 3 times 2, right? So I always look to see if the height will divide by 2, because that's what half is, divide by 2. Does my height, 4, divide by 2? Yes. So then I'm going to do that. What is half of 4? 2. And then I figure out the parentheses. 3 plus 1 is 4. So my area for my red shape, my original, is how big? 2 times 4. What's that? 8. 8 square, actually, units. And then remember shift 6 squared. 8 units squared. So we're going to repeat the process for the blue. Can the outside number be divided by 2? Can my height be divided by 2? Can my height, 8, be divided by 2? Yes. What do we get? 4. And then we do the parentheses, which is 6 plus 2 is 8. And then we do the multiplication. 8 times 2 is 32 units, shift 6 squared, right? Oh, is that 2 times as big? Did it get 2 times as big? No. How much bigger did it get? 4 times as big. So first thing, was our prediction correct that the shape got bigger? So yes, our prediction was correct that the shape of trapezoid, let's be specific. We know what it is. Got bigger. Okay. Right? We're okay with that? Okay. And this one's asking for how much bigger. Oh, we did our area too soon. We jumped the gun. We're moving this down here. Good news. We already have our work done. Yeah, you could go and copy and paste it one big chunk, but I just think it's easier to move it piece at a time. It's me. I'll go move the blue one as one. Because here it says the area. I got ahead of us. And I'm going to copy. Oh, I'm not going to copy. I'm going to actually just move it. Go like this. I want to grab you and move you down here. And then I'll get that text box to move it back. Yay. So now we have to answer the question though, how much bigger did it get? It got 4 times bigger. The trapezoid got 4 times bigger. Why? Why did the trapezoid not get only 2 times bigger? We multiplied everything by 2. Why wouldn't it be 2 times bigger? Why wouldn't it be 2 times bigger if we multiplied everything times 2? Who knows? Why do you suppose it got 4 times bigger, not 2 times bigger? Think about how we solve area to figure out why it got 4 times bigger, not 2 times bigger. Hmm? Ah, exactly. It got 2 times bigger because we were multiplying the 2 sides to make area. When we change our dimensions, we have to remember it grows by length and width. Okay, it grows in both directions, the height as well as the width. And we multiply those together to find how big our shape is because it changed the height and base. And to find area, we multiply those together. Okay? The height and base are multiplied together, no matter what our shape is. Our triangle is still base and height, but we have to times it by half to make it the triangle rule. Our rectangles, base times height. Our parallelograms, base times height. Our squares, base times height. So everything has to do with that. Both directions changed, and both those directions are used to multiply to make area. Okay? Does that make sense? So we are, by doing that multiplication, we are multiplying it and making it that much times bigger. So we're going to be looking at our areas to see how much bigger. And we remember our area multiplies the sides. So if I have a scale factor of 2, which is what that's called, it's called a scale factor because we multiplied everything by the same scale, then 2 times 2, my shape is 4 bigger. What if my scale factor is 6? How much bigger is the shape? What if I'm multiplying all my x and y times 6? How much bigger? 6 times 6 bigger, right? How much bigger? No, 6 times 6 is not 12. Because it's units squared. It's times itself. So how much bigger is a multiplying x and y times 6? It's a 6 times 6 bigger, 36 bigger, 36 times bigger. So whenever you're looking at how much bigger it gets, it's how many you multiplied by. In this case, I multiplied by 2. So 2 times 2 made 4. Okay. If it's multiplied both x and y by 6, 6 times 6, 12. So we're always taking what we're multiplying the x's and y's by and timesing it by itself, not times 2, times itself, because we multiply a length times a width, okay? Okay, so let's go look at our next one. Students in Miss Stanley's class. Hello, Miss Stanley. We're studying what happened to the graph of the shape that they made. What's the shape? What's that shape that they're looking at? What's the shape Miss Stanley's class is looking at? We were looking at trapezoid. What are they looking at? Is that a trapezoid? Really? Look at the shape on there. A triangle. Oh my goodness. So remember what just happened. Whatever we multiply by times by itself tells how much bigger or smaller. And with dilations, we can go smaller by multiplying fractions and bigger by multiplying whole numbers, okay? Smaller by multiplying fractions, bigger by multiplying whole numbers, okay? All right, so it says, what happens when each coordinate is multiplied by 1/2? Okay, think on it. Use the calculator to find the answer. And give me a sentence for what would happen if we multiplied by 1/2 for each x and y. What would happen if we multiply by the x's and the y's by half? How much bigger or smaller will our shape be? It's going to be smaller, yes, but we need a fraction smaller, not a decimal smaller. That doesn't help us. So we have to multiply the fractions together and leave it looking like a fraction. What would it be? What fraction is that? 0.25. So if I leave it looking like a fraction and I do a half times a half, top times top, bottom times bottom, what fraction do we get? Remember, when we multiply fractions, we just multiply across the top and multiply across the bottom. So what's 1/2 times 1/2? 1/4, okay. So what happens when each coordinate is multiplied by 1/2? The triangle, oops, I don't want to be in that, sorry. The triangle will be 1/4 as large as the original. And we're going to go see that happen. Okay, we're going to go graph it and see it happen. First thing, we need the coordinates on the corners of the triangle. What are our original corners on our triangle? I'm going to keep my red as my original. So I need the coordinates for at the top, I need the coordinates on the left bottom, and I need the coordinates on the left right. On the right bottom, right, left bottom, and top. So someone give me top. What coordinates is this up here? I don't think that's 8, -5, because remember our left and right comes first. -6, 8, yeah. Because we always go left and right first, okay? From the center, and if I go like this, that's -6, right? Okay, left bottom. What do we get? Left bottom, what do we get? Remember, left and right first. -2, -4. Yes. Okay, right bottom, what do we get? Right bottom, what do we get? 6, 4. Let me see. Yeah, but I don't agree with the 4. Oh, 6, -4. Thank you for the fix. 6, -4. All right, so we have our corners. Now they told us to take each one of those and multiply times half, right? So just like we did up above, we're going to take our original coordinate, which our first one, -6, 8, right? And we are going to change it by doing -6 divided by 2. That's taking half. That's what half is, dividing by 2. And 8 divided by 2. Half is dividing by 2. So what do we get for a new coordinate? What do we get for a new coordinate? If I take each one of those and I divide them by 2. So -6 divided by 2 becomes what? Come on, guys, do the math. -6 divided by 2. What do we get? -3. And +8 divided by 2. What do we get? -4. So what's our coordinate going to look like? Yes, but make sure it's in parentheses. Always make sure inside of parentheses, okay? -3, 4. So we're going to go get our blue because we are doing our new shape. It's blue. -3, +4. 1, 2, 3, 4. Okay. Now we repeat for the other two corners, right? So I'm going to just copy what I have here, change the numbers to be what the next two coordinates are, and do the math. Okay. Smart, not hard. Okay, we have a +6, 4, right? And we have a -2, -4. Oh, +6, -4, -2, -4. This should be a -4, right? And we're going to do the same thing we just did. We divide each one of them by 2. That's what half is, divide by 2. So what's my new coordinate for this next corner going to be? The one on the right. So do not freak out when you see half. It just means divide by 2. Do not freak out when it says 1/3. It just means divide by 3. Okay, so what's my second coordinate going to be? 6 divided by 2 and -4 divided by 2. What's the new coordinate going to be? Three, -2. Thank you. Okay, -2. Now the bottom one. What's our new coordinate going to be? -2 divided by 2 and -4 divided by 2. What's our new coordinate? Come on, guys. -2 divided by 2, comma, -4 divided by 2 in parentheses. What's our coordinate going to be? One, 2, there's some negatives going on in here. So what would it really be? Ah, -2, -1, -2. Watch out for your negatives, okay? So we're going to go put those two on there as well. -1, -2, and +3, -2. And then we're going to connect them with our lines that are blue. And we're going to put our coordinates on the corner. And we just are copying, pasting the coordinates that we already have. They're over here. Copy it from there. Paste it up here. Oops, no. They don't want to be there. Technology, love 8. Copy it from there, paste it there, right? Work smart, not hard. Copy it from here, paste it there. And our last one. Now, if we look at it, does it look like it got it's 1/4 as big as it was before? It's a little harder to tell with triangles. I'll show you how you can tell. Okay, I'll show you how you can tell. With triangles, just like anything else, and I'm doing this line in a different color, green on purpose, the height of a triangle is not always inside the triangle. The height of the triangle is always going to be straight up and down, okay? Always straight up and down. So sometimes it's inside the triangle, sometimes it's outside the triangle, okay? Sometimes it's inside the triangle, sometimes it's outside the triangle. So this is our height, and we know it's a height because it goes straight down. Heights always go straight down, okay? So let's go get our numbers. How high is that height for both our original and our new one? How high is this? How many spaces high is the green line? And yes, it does stop even with the base. How high? So count how high it is from the very tip down to where it's even with the base. I need those numbers because those are our height numbers. Height equals, oh no, I do want that to be blue. Our original is 6 or our smaller one is 6? Which one is 6? Our original or our smaller one? Oh, the smaller one is 6? Okay, so then I'll move that over here. Height 6. Got it. How about the original? Height of, I started at +8 and went all the way to -4. What would that be? What were we doing to our x's and y's? What did we multiply by? What did we multiply by? What does it say we multiplied by, guys? . Half. So if 6 is half of the number, how big is the other one? 12. Okay. So now we need our base. Our base is only between our two coordinates. Only between our two coordinates, okay? So how long is it between our two coordinates for the original? How far is it between the 2 points on the bottom? I need both of them, the blue one and the red one. So we have to stay between the coordinates for the base. The height is the line that goes straight down to the base. Sometimes it's in the triangle, sometimes it's not. So how much space is there between on the little? 4. Okay. How much space is between on the big? 4 is half, then it has to be 8. Okay. So now we're going to do the math. For triangles, okay, for triangles, the area is half times the base times the height, okay? It's kind of an easier formula than the trapezoid because the trapezoid's just weird, okay? So we're gonna go put our numbers in. For the red one, that's the original. That's the original. My base number was 8. My height number was 12. It doesn't matter who I divide by 2, but only one of them will divide by 2. Only one of them gets the half. Does it matter which one we give the half to? No. I prefer to give the half to the bigger one to make it a smaller number, but it doesn't matter. What's half of 12? What's half of 12? 6. So really this is telling me 8 times 6. So what is 8 times 6? What is 8 times 6? 48. And 48 units to the second power, right? That's my original. Now I'm going to go repeat with my blue one, my little guy numbers. Okay, so I'm going to take the second and third, take this one, and put it over here. And we're going to be, base was 4 and height was 6. So we have to do half of one of those. Does it matter who we take half of? No. Take half of one of those. Tell me what you would have. What two numbers would you multiply together? Take half of one of those. It doesn't matter. Okay, take half of 6. What would we get? Since you guys can't pick for yourself. Take half of 6. What do we get? 3. Okay. Times the 4 that's still there. So how big is that? If we do that math, what's the area of the little guy? 12 units squared. Okay. Is 12 units squared 1/4 the size? Can you multiply 12 times 4 to get 48 is the question. Okay, so we proved that it's 1/4 as big with our formulas. Okay, now the good news is we do not have to redo anything for the big triangle. We just have to work with the small ones. All right, so let me get this a little smaller because I want to see the big. Now, what happens if we multiply x's and y's times 1? So on this one, we said that because we multiplied by 1/2, the triangle was 1/4 as large as the original. If we multiply the x by 1 and we multiply the y by 1, what's going to happen? Is anything going to happen? Is anything going to happen? If I multiply the x times 1 and the y times 1, does that change anything? No. So is something going to happen, or are we going to not change? We're not going to change. So we are going to have the same triangle as the original. So what were those coordinates? We get to make blue dots for them though. -6, 8. Okay. 1, 2, 3, 4, 5, 6, 8. And then we had a 6, +6, -4. Right? And we had a -2, -4. And we connect them with our lines and we put the coordinates on the corners and we're done but other than writing our sentence answer to their question. What are we going to say is our sentence answer to their question? What are we going to say is the sentence answer to their question? Is what's going on with our triangle? What changes when the coordinates are multiplied by 1? We have to answer that question still. What changes for the triangle when the coordinates are multiplied by 1? It has to be a sentence and it has to be using their words that they already had. So rearrange the words from the question. Rearrange the words from the question. The triangle will what? Look how we answered the first one. Use that same kind of pattern for the second one. The triangle will be what? We need our sentence answer so we can move on. Please, someone give me the sentence answer. Look at how we formulated this one. And what did we say would happen if we multiplied everything by 1? So we need to do our sentence answer, please. Come on, guys. I'm not writing it for you. You guys need to participate, and we still have 1, 2 more to go. So can we get this sentence answer done, please? If we multiply x's and y's and numbers by 1, will we be smaller than the original, larger than the original, or the same as the original? So will you please formulate a sentence for me that does that for us? The triangle will be what? Does multiplying by 1 change your values? Thank you, Lily. The triangle will be the same size as the original because multiplying by 1 changes nothing. That is why we just copied the exact original triangle. Okay, now we're multiplying times -1 for the x and the y. So let's go get our calculation stuff. I'm going to go up and get this set of work we did here. So I'm going to go copy that group of work. We need this right here. So I'm going to copy it, move it down here. I'm going to paste it, but I shifted too soon. Still getting used to that. Go. Copy, copy, paste, then drag it down here. Come on, go, go, go. I can put you here to start. Slide you a little bit. Why aren't you letting me go on the next page? Oh, so we have to copy you again. Why isn't it letting me onto the next page? This is crazy. So I have to copy it again here and then move here. Make sure I move down there. Oh, but I should probably be like that. And paste. No, it didn't let me do it. So. See, it's not letting me onto the next page. So I'm just going to do it the old-fashioned way. Forget it. I'm going to go one piece at a time. It's okay. I've got it this far. I can grab it and drag it down here. Or not. Oh, lovely. Okay, so how much is it saying we're multiplying by once we get this technology stuff under control? How much are we multiplying by? -1. And we already learned before something about -1. Okay, thank you, Charlie. I might figure it out next period. I did last time. Okay, so what did we figure out before happened with multiplying by -1? It said at the very top of the page. So I'm going to be taking -6 times -1, And I'm going to be taking positive 8 times negative 1 and getting my new coordinate. What am I going to get? Negative 6 times negative 1. What do we get? Positive 8 times negative 1. What do we get? Tell me the coordinates. Tell me the coordinates. Positive 6, negative 8. Okay. Do our next one. Negative 2 times negative 1. And negative 4 times negative 1. So what would our new coordinate be? What's our new coordinate? Negative 2 times negative 1. Negative 4 times negative 1. What's our new coordinate? Come on, guys. 2, 4. Thank you. Okay, last one. Negative 6. We already did that one. Positive 6, negative 4, right? Positive 6, negative 4. That was our last coordinate. One second. Let me get it written. That's going to flip it to be a negative 6, positive 4. Okay. So now we're going to go graph those. Okay, positive 6, negative 8. So 2, 4, 6. I got to zoom in a little bit. Thank you. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then our next one was positive 2, positive 4. And negative 6, positive 4. And we connect them. What happened? Did it change size? Did it change size? Is this a bigger or smaller than the original? Did we change its size? It's the same size, but what happened? Is it just upside down? Let me zoom out for a second. I'm putting coordinates on. Give me 1 second. So it's not a different size. It did not 1 flip, but 2. So let's look. Let's go back to our original. Here's our original, right? So 1 flip would have just brought us down or left and right. Yes? But this one went down and left and right. It did a double flip because the X was changed by -1 and the Y was changed by -1. What is another function we have that would have put it here? Do we have another one of our transformations that would have put it here? Let's look. I'm going to copy it and see if it'll do it for me. I'm going to take this triangle I just drew, okay? And I'm going to move it up to the top. You don't need to. I'm doing it to show you. I think I got it. There, Charlie. See, I did it, right? What happened, right? And I'm going to paste it up here. It did this. You don't need to do it. Please don't. I'm just doing that so you can see. What other one of our types of rotations do this? See, look, rotations do this. Sure. So when we multiply the x and the y by -1, we get a rotation. How many rotations? Look, it has a little rotation figure on it. No, didn't work. Did we go 1 tick mark or 2? 2. Did we go clockwise or counterclockwise? Does it matter? If we do 2 ticks, it doesn't matter. So it went a rotation of 2 tick marks is how many degrees? 2 tick marks is how many degrees? 180. So when we go ahead and we multiply the x and the y by -1, we create a rotation of 180 degrees. Okay, I'm gonna take that back out. I just wanted you guys to see it. Okay, so oops. With that in mind, I'm gonna make this a little smaller. What do we think is going to happen when the coordinates are multiplied? So we have to answer their question. What happens when both are multiplied by -1? What are we going to say? The triangle did. The triangle. What are we going to say the triangle did when we multiply x and y by -1? We have to answer their question. Rotates. What's the real phrase? What's the real numbers and stuff for 2 ticks? Rotates. How far? 180 degrees. Now, oops, sorry, degrees. Now, does it matter if I say clockwise or counterclockwise? No. So I'm just going to say clockwise because that is our normal way we spin things in our world, clockwise. Okay. All right. So now we're going to pull the things together. This is multiplying times a -2. So what do we think is going to happen? If we pull the concepts together, the negative part is going to make it do what? The negative part is going to make it do what? What did we just figure out? The negative part does. Rotate, yes, 180 degrees. The 2 part is going to make it do what? What's the 2 part? So we know that the negative is going to make us rotate 180 degrees clockwise, right? It doesn't matter if we say clockwise or counter. And the multiplying by 2 is going to do what? Does that make us bigger or smaller, and by how much? Does that make us bigger or smaller, and by how much? If we multiply by 2. Think back to the ones we did at the very beginning. Does multiplying by the 2 make us bigger or smaller? bigger by 4. So it will make, and 4 times as big as the original. Okay, and we have to say rotates 180 degrees clockwise from the original. Okay, so 4 times as big. So let's get our work. It's on the screen already. I'm going to copy and paste this part, and we're going to change it to the times 2. Okay, because it's already on the page for us. Yay! Copy, paste, move you here. Change our number from -1 to -2. So -6 times -2, -8, +8 times -2. What's it going to change our numbers to? Someone give me those coordinates, quick, quick, quick. We're getting close to the end of the period and I want you guys done. So what's our first coordinate going to be? Multiply what we have by 2, 12, and -16, right? Because this was just -1. So we're doing -2 now. We're just taking what we had from the last one and multiplying by 2. Okay? And graph it and put those coordinates on it. And I'm going to give you 5 minutes before I'm going to close this up. So go ahead and get those graphed. Quick, quick, quick. 1, 2. Can I fit -16 on here? No, I've got to make my lines worth 2. Okay? Because this only goes out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can't fit. So I have to go by 2s. Okay? So step 1, we're going to say that this is 20. No, 2s, 24. Okay? So you have to go by 2s. I will give you till the end of lunch to finish graphing this one before I expect it to be turned in. So that means I'm expecting to see it turned in by the time I go to my 4th period class. So you have until 12:44. What correction? Okay. You have until 12:46 to finish graphing this one. Remember, each line is worth 2. Are we clear? Okay. Have a great day.